All right, Year 12s, welcome to our video on learning to use the chain rule for differentiation. So before we start learning the chain rule, we're going to first talk about what it is that we can already do, and then what are the things that we can't do that make us need something new, a new method. So the things that we can do that I've shown you there, differentiate functions involving power functions. For example, x cubed plus 3x squared plus 11. That's actually a polynomial function, but x cubed on its own is a power function and 3x squared on its own is a power function. So when I put those together and add them up, what I'm left with in this case is a polynomial. But my second example is not a polynomial because the first power is a negative power, 2x to the power of negative 4 minus 5x squared. But they are two power functions and they're added together, and I do know how to differentiate each term, which means I know how to differentiate the whole thing. I'm going to use the same rule of multiplying the power by the number in front so that I get negative 8, and then I subtract 1 from the power so that I get x to the power of negative 5. And then my second term will become minus 10x. That's to differentiate the second function there. So those are the things I can do. What about the things that I can't do? I can't differentiate a composite function. At times I can. For example, if that was x minus 7 squared instead of x minus 7 to the power of negative 2, I'd be able to expand it and then differentiate. I can do that. But the example given there, I can't. I can expand it. I can write it as 1 over x minus 7 squared. But if I expand that, I end up with a quadratic function on the denominator of my function. So that's not really useful to me in terms of helping me to differentiate that. So I can't do composite functions. I can't do products of functions like in the example shown. But we are going to learn how to do those. And the first thing we're going to learn is composite functions. And in order to differentiate a composite function, I'm going to use the chain rule. That's what it's for. So what are the key skills to be able to use the chain rule? The first one, and this might seem really obvious, but it's often the hardest thing to do, is recognizing that a function is composite and therefore I do need to choose the chain rule. Of course, today we're going to be focusing on exercise 9E, which has lots of chain rule examples. And so we know we're in 9E and that we need the chain rule. But if I'm in an exam and I've got a question, there's nowhere there that's going to say use the chain rule to do this. I need to know when to decide to use the chain rule. And that's the answer to that question. If the function is composite, then I need the chain rule. The second part is, once I've figured out I have a composite function, I need to identify the inside and outside functions. And I'll show you that in the examples that I've got. And then finally, I need to be able to apply the chain rule. So I'm going to start with an example, but I'm not going to immediately start with the chain rule. I'm going to start doing this example the way we already know how to do, which is by expanding. If I've got y equals x plus 5 cubed and I need to differentiate this, I'm going to use, not that pen, hang on. I'm going to use my binomial expansion, a plus b cubed equals a cubed plus 3a squared b plus 3ab squared plus b cubed. You guys should know that one by now. If you haven't, it should definitely be clearly in your notes and you should try to learn it. It's easy to remember. So I'm going to apply that here. So the first term is x and the second term is 5. So I'm going to have x cubed plus 3 times x squared times the 5 plus 3 times x times the 5 squared plus the 5 cubed. And this gives me x cubed plus 15x squared plus 75x plus 125. Okay, that's what y equals. So I can now find dy dx. It's going to be 3x squared plus 30x plus 75. Done. All right, so what's this chain rule? The chain rule is fairly simple to write down. Dy dx equals dy du times du dx. Now, it is possible to use the chain rule using f of x notation. I find it much more straightforward using dy dx notation, so that's what I'm going to show you. So first of all, I have some key steps to finding the chain rule. Okay. The first step is recognition, and I've already talked about that. If I look at this example, x plus 5 cubed is a composite function because I have one function x plus 5 which is then has another function done to it, which is the cubed. All right. My second step is I have to define u. So let's follow these steps for this example. Y equals x plus 5 cubed. So I know that I want to use the chain rule. I'm going to say let u equal x plus 5. I've defined u. Okay. My third step is to write y in terms of u. So at the moment I've got y equals x plus 5 cubed. I'm going to rewrite that as y equals u cubed. Oops. Shift that so you can see it. Okay, can I fit all this on the screen? All right, my fourth step is now to differentiate. I'm going to differentiate each of these two equations, y in terms of u and u in terms of x. So I find dy du, because that's going to go into the equation there, and I need to find du dx, because that's going to go into my equation there. So dy du, I've got y equals u cubed, dy du equals 3u squared. I've got u equals x plus 5, so du dx is just 1. It's a nice easy one. My fifth step, I apply the chain rule. Dy dx equals dy du times du dx, which gives me 3u squared times 1. And I'm not quite done. My sixth step is I need to substitute u. So I've got 3u squared in this equation. I actually need this to be in terms of x, so I'm going to replace u with x plus 5. So dy dx equals 3 times x plus 5 squared. Okay, so I've now, oops, sorry, you can't see that. There we go. So I've now differentiated this twice. I've done it once by expanding and then differentiating, and I've done it another time with the chain rule. Probably in this example, it looks like the expansion method was the quickest way. Either way is correct. There's no right or wrong way to do this as long as you get the right answer. But let's look at this example here, this answer here. If I take out a common factor of 3, I've got 3 times x squared plus 10x plus 25. Okay, we can all see what that is. 3 open bracket x plus 5 all squared, which is exactly what I found using the chain rule down here. So I'm getting the same answer. It doesn't matter which method I choose. However, there are times when I'll need the chain rule because there is no alternative way. If I can't expand it in a way that helps me find the answer, I'm going to use the chain rule. Okay, I have another example to show you. I've already written out the working to this one. And I'm going to put it side by side with the steps so that we can see that we did all the steps. If it all fits. Not quite. Okay, I'll jump it on and off. So my example is differentiate y equals open bracket 4x cubed minus 5x to the power of -2. I'm going to use the chain rule because this is a composite function. Inside the brackets, I have a cubic function, 4x cubed minus 5x, and then the brackets are raised to the power of -2, making it a composite function. So my first step is to recognize that I need the chain rule. My second step is to define u, so that's what I've done here. U is always the inside function, so it's 4x cubed minus 5x. My third step is to write y in terms of u. So I've replaced 4x cubed minus 5x with u here. Okay, it's the same function otherwise, y equals u to the power of -2. So now I've found y in terms of u and u in terms of x. I'm going to now differentiate both of those. I'm going to find dy du and du dx. At this stage, those steps are pretty simple. Take this -2 out the front, giving me -2 times u. This power has to be 1 less than this. So I go -2 minus 1 gives me -3. This one over here, the 3 times the 4 gives me 12x squared minus 5x. Minus 5x becomes -5. All right, now I apply the chain rule. dy du times du dx is going to give me the derivative dy dx. So I substitute dy du is here, du dx is here, and in my last step I replace u with 4x cubed minus 5x. and then I'm pretty much done. Don't be tempted to try and expand or simplify here unless there's something really obvious that's going to simplify. That is the answer. I don't need to do anything further.